All right, let's review some things we've talked about over the last several lessons, really since the start of the quarter. And most recently, we talked about having similar polygons, and we also looked at the perimeters of these similar polygons. What is perimeter again, Ethan?
It's like all the sides.
All the sides.
The something of the sides. The sum of the sides?
The sum of the sides, there we go, is the perimeter. And we said, what will be true about the perimeters of similar polygons, Genesis? If two polygons are similar, what do I know will be true about their perimeters compared to each other, shall we say? Kendall, help her?
The perimeters will be in proportion to the side.
Good, the perimeters will have the same ratio as the sides. That is, that the perimeters will share class the ratio of similitude. So, Genesis, coming back to you, we could make what proportion with any two similar polygons and their perimeters? Good, perimeter is to perimeter as side is to side. That's for similar polygons. Before we talked about that, of course, we had some special triangles. Don't want to give the live audience any sort of unfair advantage over my YouTube audience. One of our special triangles was what we call an isosceles right triangle, but we call it by another name, Chris. It's not a name, but a number.
45, 45? 45, 45, 90?
There we go, 45, 45, 90, but it's an isosceles right triangle, right? But the angles are 45s, there we go. And with the 45, 45, 90, how do I label the legs, Chris?
X, X.
What? What's X?
The ones across from the 45-degree angle.
Oh, okay, the ones across from the 45-degree angles, or we would call these the legs. There we go, are each X. And
that's why I confused. You said, what would we label the legs?
There we go, label the leg. Did I say legs?
Yeah, that's what you said.
I actually said legs. Okay, my apology. We label the legs X and X, okay, and then the other side called the
hypotenuse.
We label
X squared.
I'm sorry, I didn't realize I already used the term legs in there. There we go, XX for the legs, and then X squared 2 for the hypotenuse. The other special triangle that we had was really half of an equilateral triangle. And what do we call this triangle, Jamie?
What we call it? It's the 30, 60, 90.
We're going to call it a 30, 60, 90 because we have a 30-degree angle. That's the bisected vertex angle of the equilateral triangle. Of course, we have the full 60 here. And we have the 90 caused by that bisecting altitude being drawn down. How do we label the sides? As I said, sides. How do we label the sides here?
The one across from the 30 is X.
So that would be our short leg is across from the 30. That's X. Good.
The one across from the 60 is X times the square root of 3.
Good. That would be our longer leg, X times the square root of 3.
And the one across from the 90 is 2 times X.
And of course, we call this side the hypotenuse is 2X. That'd be double the short, and this would be the square root of 3 times the short. Okay? From there, we'd also, this kind of built on the back of really any right triangle. And we said with any right triangle, if I know two sides, I can always find the third side, Quentin, using the Pythagorean Theorem. So any right triangle, Pythagorean Theorem, we don't have to know anything special about it. Of course, with the Pythagorean Theorem, which is, there we go, or in words, what would that be? Audrey? Good, hypotenuse squared equals leg squared plus leg squared. Good, but again, this is true for any right triangle. The difference is here you've got to know two sides to get the third side. With these triangles, you only have to know one side to find the other two. That's what makes them special. So for instance, let's take a right triangle here. Let's call it QRS. And suppose I know that RS is, say, 5 centimeters. Suppose I know that QS is 3 centimeters, and I wanted to find QR at your seats. question.
I think I just realized the answer has to be what it is because you did 5 and 3. And it can't be. Never mind. Can I say the answer?
Sure, Chris, what's the answer?
4. But it has to be 4 because it can't be bigger than RS. I suppose it could be anything below 3, but.
Right, so for instance, how many got 4 centimeters, by the way? All right, we should have plugged in for c squared. That's the hypotenuse. In this case, the hypotenuse is RS. RS is 5. 5 squared equals. And then for A, it could be either of the legs. Let's just say QS, which is 3, would go here. And then QR would be your other leg, this here. So 25 is equal to 9 plus B squared. Bring that 9 over to negative 16 equals B squared. B equals 4. Let's suppose for a moment, though, that I didn't know 5 and 3 here. Let's suppose I knew, let's suppose I know that QS is 10 inches, or RS is 10 inches. QS is, say, 8 inches. Find QR. Chris?
6.
No. Correction, yes.
Oh man, I thought so.
I got saved down. My depression went up 100.
Not drawn to scale, right?
Yeah.
What do we do to plug it in here, Genesis?
10 squared, 8 squared.
There we go, where we square the 10. We square the 8 plus b squared, but we have to get. And of course you could use calculator if you needed to. Help, class? 36 equals the b squared, and that's where Chris got the 6 inches there. Let's do one more very quickly. Supposing that we knew that QS is 7 feet, and supposing we knew that QR is 5 feet. Find RS. And it's going to be pretty ugly, isn't it, Quentin? What do we end up getting for RS, Quentin? Yeah, the square root of 74 feet. I don't want a decimal, but you can't reduce the radical. There's no squares in 74, so you just leave it. Square root of 74 feet. How many have that for this one here? Now, if we took the same picture, but we now drew an altitude down here, let's call it QT. Nice. Now, all of a sudden, we could still use Pythagorean theorem here, couldn't we, class? In fact, we could use Pythagorean theorem just as we were. We could use Pythagorean theorem right here, leg, hypotenuse, leg, hypotenuse, or we could use some proportions. What proportions could we use, Kendall?
Segment next to altitude.
Meaning the other segment, right? So I'll go segment prime. What's another proportion we could use here, Ethan?
Segment is the leg, is the hypotenuse.
There we go. This would be the exact same leg again. And of course, we could do that a couple different ways, couldn't we? So suppose I knew that QT was 2. I guess that would be Renee, my little 2-year-old. ST is 4. ST stands for stinker. That would be my older son. And QS, well, we're finding QS. And there's 2 different ways you could do it. Certainly the most direct way to find QS class would be to use Pythagorean Theorem, right? We've got the three sides of a right triangle, so it would make a lot of sense to say that x squared, which is the hypotenuse of that little triangle, equals leg squared plus leg squared, in which case we would get
4 plus 16, so 20.
square root of 20, which would be 2 times the square root of 5, and I didn't give you any units. That's one way to do it. But the alternate way to do it, you could say, well, there isn't a proportion that has segment is to altitude as something is to leg, right? But I do have segment is to altitude as altitude is to segment. And so I could go with the proportion 4 is to 2 as 2 is to x, in which case x class would be 1.
Not drawn to scale.
Not drawn to scale at all. Already know that because this is 4 and that's only 2. But that means that the whole of RS class would be 5. I do have a proportion now that says segment is to leg is to hypotenuse. And we could say 4 is to x as x is to 5, and we'd still get 2 times the square root of 5. A couple ways we could work that problem. Questions on that?
I wish I would have solved Pythagorean Theorem. I could have been so much faster.
Yep. Let's suppose we had this picture, a circle with a chord drawn here and a chord drawn here. Let's call this chord AX. Let's call this chord BY. Let's suppose these chords intersect at a point called M. Now this doesn't have a proportion that goes with it. What fact goes with this picture, Jamie?
Is it the product, or is it like AX, AM is to, alright, plus times MX equals BM times MY?
There we go. The product of segments equals product of segments. So, for instance, let's suppose we knew that BY was 8, MY was 6, AM is 4, and I wanted to know the length of MX at your seats. Ethan's fast. What you get?
12. That's fine. Oh, I was thinking those were both say. Dang it. I wonder. Sorry.
So Ethan, when he plugged it in, treated BM as if BM were 8, but BM's not 8. BM is only
X.
BM is
oh, yeah, 2.
2. And we'll call MX our X. So really, we should have gotten class X equals 3 for our answer.
Question.
Yes, sir.
So, you really could have just done 6 times 2 and then gotten 12 and divided by 4 or whatever and figured out the answer that way, right?
Yeah, that's exactly what we had to do. That's the only way to do it. All right, so let's suppose we had this picture. We have a circle with a tangent FG and a secant FHI. What proportion goes with this picture, Chris?
Secant, or no, tangent is to secant. Secant is to tangent, tangent is to external segment.
There we go. Secant is to tangent is to external segment. Suppose I knew that FI is 10 and HI is 6. I want you to find FG. Audrey, how do I set up the proportion here?
10 is to x is 4.
Good. 10 is to x, as x is to 4, that would be your external segment. What did you get for your tangent? Good, 2 times the square root of 10 units. Everybody got that answer? Any questions? All right, clear desk except for a clean sheet of paper, pencil, and calculator. Clean sheet of paper, pencil, and calculator.
Am I gonna need a pen for grading it?
We are not grading the class. So sheet of paper, pencil, calculator. Everything else away.
Is the paper a cover sheet?
No, for you to work on. First, let's name the top of your paper along with today's date, which is 4/9/21. 4/9/21, today's date. First and last name, 4/9/21, today's date.
Do you need a calculator?
Yes, calculator is recommended, though not necessary. You can do all the work without it if you had to. All right, let's go and take a look at the quiz together. This is quiz 35, not a 35A, by the way, if that makes you happy. Just quiz 35 for a change. True or false? Write the entire word true or the entire word false. And then for numbers 6 through 10, you're going to solve the problems. Note that 6, 7, and 8 all use the first picture. 6, 7, 8 all use the first picture. They're individual problems. They don't build on each other, but they all use the first picture. 9 uses the second picture. 10 uses the third picture. 11 does not have a picture. All right. Use the quiz copy as a cover sheet, and you may begin. We just have 20 minutes remaining for the class. We're not going to use all of that for the quiz, but you have about 10 minutes still for the quiz. If you're watching on YouTube, we're on a special schedule today, so the bells are going to ring a little bit strangely. have about 5 more minutes to be finishing up, so still plenty of time to work carefully. Obviously, don't allow yourself to get stuck on a single question now. Several people finishing up now. Still got about 2 minutes remaining. Go ahead and take your textbooks out if you would please, and turn to page 219. Page 219. Page 219. Let's look at the top section, the section 4.15, exercise number 3. So section 4.15, exercise 3, and read that for us if you would, Quentin.
The triangle ABC is inscribed angles. M is the midpoint of arc A and B, and DM intersects AC with B. Prove AB is BC as AB is BC.
All right. What should we draw first here, Quentin? Right, he mentions a triangle first, but it's really hard to draw a triangle and put a circle around it. So let's actually start by drawing the circle. And of course, inside, draw a, which we will call
ABC.
ABC. What else should we put in this picture? You're doing this along with me there, Genesis. All right, what else? I know you're like zoned out. It's Friday, tired.
Yes.
Well, I just wanted you to get your paper up so you can be working along with us here. But we could come to you, except you're in the middle of getting the paper out. What else does need to be in the picture, Audrey? Which would be. So find on your picture where AC is and try to locate to the best of your ability the midpoint of that arc. I'm going to go ahead and mark segment these arcs equal to each other, though technically I do still have to put that in the proof. I also need to draw what else? Chris?
BM.
BM. So all the way there. And it does tell us that where BM intersects AC, this point, class, we've got to call D. All right. So I think that's it. So given, I'm just going to say inscribed triangle ABC. Since I didn't name the circle, I won't mention the name of the circle. Given inscribed triangle ABC, given that M is the midpoint of arc AC, the presence of the other chord and all of that doesn't have to be stated. It's evidenced by the picture there. What are we trying to prove, Chris?
AB is to BC, as AB is to BC.
AB is to BC as AD, there we go, is to DC.
Except they don't have an fraction form, but yeah.
Well, they don't have them in fraction form, but we always write them in fraction form. Go ahead and get down 2 columns, statements, reasons. I'll get down your first statement and your first reason. And we do have some clang we need to take care of right up front, Jamie.
AM is equal to MC.
Good. Arc AM equals arc MC, and reason.
Because the midpoint slice in half.
That would be the
Definition of a midpoint.
There we go. Definition of midpoint. Number angles. You're talking about the ones at D?
Yes, and at B.
And at B. In fact, those are actually the ones I care more about for now. I'm going to go number these angles 1 and 2. What are your thoughts there, Quentin? Because these angles are inscribed angles, and we know an inscribed angle equals have its arcs, so these angles are both halves of their arcs, but their arcs are, now of course, we're doing a lot of mental steps. They do need to make it onto the paper, but ultimately we know those 2 angles are going to be equal, correct, class? So let's start with the very beginning, and that was, we know what about angle 1, class?
Equals half of its arc.
Half of MC. And we also know that angle 2, half of arc AM, because the inscribed angle equals half its arc. All right, and then of course, because AM and CM are equal arcs, 1 and 2 are halves of equals, so number 4, someone else.
Oh, angle 1.
Angle 1 equals angle 2 because halves of equals are equal. Now, by the way, if I have equal angles, that would make this line
Perpendicular bisector.
not a perpendicular bisector, an angle bisector. Good, Genesis. So number 5, we might state that.
Angle BMC.
BM.
Oh, no. Angle.
What did you say had to be true, Genesis? Since 1 and 2 are equal, you said that BM is a... So let's go ahead and state that. BM is the bisector of angle B. And the reason, of course,
Definition of perpendicular.
angle bisector. Right, it bisects the angle bisector. All right, any other claiminess? Because I mean, this claim kind of midpoint equal arcs. Well, equal arcs got us equal angles. Equal angles gives us a bisector. What?
Inscribed triangle. That's not really a claim, is it?
Yeah, I'm sorry?
I don't think there's any claim.
No more claim? All right, so let's look at what we're trying to prove now. I'm trying to prove AB is to BC as AD is to DC. When we want to prove lines proportional class,
Triangle.
similar triangles,
See,
and then CSSTP. So what triangles need to be similar here? Kendall?
ABD, triangle, ACD.
So these two triangles here would need to be similar to each other. And when we get triangles similar, we like to use angle. Well, we've already got one set of angles taken care of, right? 1 and 2. So if we could get, let's see, I'm gonna put my D right here. Call these 3 and 4. If we could get 3 and 4 equal, then that would be angle, or perhaps angle A and angle C equal, right? Then that would be angle as well. Now, if these angles were equal, what would be true, class? Besides angle.
Arcs would be equal.
The arcs would be equal. Do I know that these arcs are equal? No, and I shouldn't assume they are. Not only would the arcs be equal, but these lines would be equal. This would be an isosceles triangle. Do I know it's isosceles? Should I assume it's isosceles? So I can't assume A and C equal. Do we understand that?
D.
Which also means, by the way, 3 and 4 wouldn't be equal, because then if they were equal, we'd have equal angles when two straight lines intersect. These would be right angles. Well, I don't know that that's perpendicular. I can't assume that. So instead of maybe 3 and 4 equal, maybe say instead angle C would equal maybe angle 4, right? Since I couldn't say A and C equal, but there's a problem with that. 4 can't equal C. Why not?
C equals half of arc AB and 4 equals half of arc
Hey, that's a good read. That's not what I was expecting you to say, but that works. C is half of AB, 4 is half of AB and CM put together. It can't possibly be, but also 4 is an exterior angle to this triangle. An exterior angle is always greater. I cannot get those triangles similar. They are not similar.
Time for Pythagorean.
Well, let's see here. All right.
Class is over.
Well, here's what we can do. Here's a thought we could throw out there. What if we alternated the BC and the AD? Right? To say that AB is to AD as BC is to DC. Realize if I could prove this, then this would have to be true by alternation, right? Use a transformation to help us out. All right, now what triangles would we need to look at? ABC, which is the big one, and ADC, which is a straight line.
Anyway.
That's not going to work.
Auxiliary lines. Auxiliary lines.
So, yeah, we've got a real problem here, don't we? We cannot use similar triangles. Remember I said most of the time, when we want to get lines proportional, we're going to get similar triangles, use CSSTP. But there's a reason I said most of the time. It can't always be used, and it can't here, but there's something else we have. We have a triangle
The cat system.
with an angle bisector.
I was thinking that earlier.
And anytime, Ethan, we have a triangle in which an angle has been bisected, we know that
Bisects the base.
no, that would be an isosceles triangle. Anytime I've got a triangle with an angle bisector, Chris.
Segment is to altitude, or segment is to leg.
Ugh. This goes way back. Segment is to
It's
segment,
side to
as
side.
side is to side. And here I have an angle bisector, so segment is to segment as side is to side. You mean segment is to segment as side is to side? Yeah. So as soon as I say I've got the bisector, number 6, I'm done. AB is to BC as AD is to DC. Because if an angle of a triangle is bisected, then the segments of the opposite side are proportional to the other two sides. If an angle of a triangle is bisected, then the segments of the opposite side are proportional to the other two sides. And this is really the only time this entire year we're going to do a proof where angle, similar triangle, CSSTP doesn't work. But I wanted you to at least see it. Some information for you very quickly. We will take a test next Friday. That'll be in lesson 151. That'll be over sections 4.4 to 4.17. You have homework this evening. It's a handout. It's a very long handout, but it's not due until lesson 148, which is Tuesday. So you have tonight, Saturday, Sunday, and Monday to do it. But don't wait till Monday night or you will be a miserable individual. It is 3 pages long. So that's why I'm giving you 4 days to work on extra long homework handout. It is in the description of the video. It is not included with the other handouts from the semester. So work a little bit each night on it, get a few problems, work them through, and then we'll go over it on Tuesday in lesson 148. Again, test Friday in lesson 151. All right, you are dismissed. Have a wonderful rest of your day and a great weekend.